Hello, welcome to 8-2, the axis of symmetry and the vertex algebraically. So today we're going to be learning about a very special feature of the quadratic that you can find just by looking at its graph, but occasionally you need to find the algebraic way. There's also a really cool way of doing it once you find out what its roots are, but we'll go over that towards the end of the unit. And it's actually a relatively new way that we started approaching them when we actually find out what their roots are, because it's all about the way the form of the quadratic is, which you're going to be seeing over the next few weeks. So today what we're going to be looking at is the axis of symmetry, and we learned yesterday that the standard form of a quadratic is y equals ax squared plus bx plus c, where a, b, and c are just numbers. So for instance, if the first question states, why is a not allowed to be 0? Well, the thing is, if we said that a was 0, then we would have y equals 0 x squared plus bx plus c. The thing is, we never write 0. So we would just have y equals bx plus c, which means that we don't have an exponent, which means that we don't have a parabola. That's why we can't have a 0x squared. We need to have a number with our x squared, okay? Which means that this would actually become no longer a quadratic, it would become a linear function, because linear functions do not have exponents. Okay, let me just write a quick note, linear. So for our first example, I'm going to say again, you need to have a graphing calculator or you need to have Desmos on you. So what I would do is pause the screen, go back and forth between Desmos so you can see where I'm getting the points. So the first thing it says is graph y equals x squared minus 4x minus 5. So I copied and pasted this table from Desmos. Remember, the whole goal with quadratics is to see numbers repeat. I have a 7, and then I have a 7 downstairs. I have a 0, and I have a 0 upstairs. -5, -5, -8, and then I got the lone -9. Those are the points we're plotting, because that's where we see our pattern. So the first thing we want to plot is -2, 7. I'm going to change the thickness of this. So I go out 2, up 7, 1, 2, 3, 4, 5, 6, 7. I plot -1, 0. I plot 0, -5, so 1, 2, 3, 4, 5. I plot 1, -8, so -6, -7, -8. I plot 2, -9, so 1 less than -8. And then I plot 3, -8, 4, -5, 5, 0, and 6, 7. And look, we know we did it right, because look, our graph looks like a parabola. I'm going to do my best to connect them. So I'm going to zoom in. And it's not perfect, but it'll do the job right now. Remember, we always end our graphs with arrows, because they go on forever and ever and ever. So the first thing we want to do is we want to find out what our axis of symmetry is. Our axis of symmetry is an x equals. The reason why it's an x equals is because, look, it's a name. X is. So x equals. We look to see where there's no more of a pattern, but where our pattern begins again. And it starts at 2. Because, look, it goes from -8 to -8. So my axis of symmetry is x equals 2. And we know that our vertex is our turning point. It's where our axis of symmetry occurs. So it is 2, -9. Okay? So here's the issue, though. That's such a long process to graph, to go to our table, to do all of this. So here's what we do. We do this thing called axis of symmetry algebraically. It's just a formula. -b over 2a. So to find your vertex algebraically, you have to find your axis of symmetry. So to find our axis of symmetry, we simply just do the formula. and we do negative b over 2a. So for example 1, we want to find the axis of symmetry and the vertex of the graph above algebraically. So what I'm going to do is rewrite our equation. Y equals x squared minus 4x minus 5. The first thing we do, this is going to be very beneficial, we need to find our a, our b, and our c. So a equals, b equals, and c equals. So a is always our start. Because it's like the alphabet. You start with a and then you end with c. So the number attached to my x squared is a 1. The number attached to my b is a negative 4. And my c is a negative 5. You need to make sure you're cautious of your signs. Our next step is to rewrite our axis of symmetry formula, which is x equals negative b over 2a. So we now look at our values. We substitute. We get x equals negative. And I'm going to encourage you to practice safe math and to always use parentheses when substituting. So when I plug in my negative 4, I put in a negative 4 for b. And then I do my 2, and then I substitute my a. I get x equals negative negative 4, which just becomes a positive 4, over 2 times 1. 4 divided by 2 is 2. So x equals 2. That is your axis of symmetry. Now, to find our vertex, we take that x equals and we simply substitute it back into our original equation. So I'm going to go to the side. We're now going to plug in 2 into y equals x squared minus 4x minus 5. So we do f of 2 equals 2 squared minus 4 times 2 minus 5. You can type this all into a calculator and you are going to get negative 9. Practice safe math. Use your parentheses. But remember, this is a y value. This is a x value. Your vertex is a point, so you need to write it as a point. So my vertex is 2, negative 9. That is your final answer. So this is a very beneficial technique. It actually helps you find the axis symmetry and the vertex quickly. It defeats the purpose of graphing, and it defeats the purpose of completing a square. But it's most useful when your equation's already in standard form. So what I would recommend is trying to do this example number 2, finding the axis of symmetry and the vertex algebraically by yourself. If you want, you can follow along, or you can try to do it yourself. Just remember, you will need to do these things by yourself. So I have y equals x squared minus 3x plus 2. The first thing I do is write my a, my b, and my c. So I'm going to zoom in and do my a, b, c. You know me, 1, 2, 3. So a is equal to 1, b is equal to negative 3, and c is equal to 2. Negative 3, positive 2, positive 1. Circle those numbers. Make sure that you see the sign. Our axis of symmetry formula is x equals negative b over 2a. We get x equals negative of negative 3 over 2 times 1. Negative of a negative 3 is a positive 3, so I get x equals 3 over 2. Because 2 times 1 is 2. If you want, since we don't really like fractions, what we can do is we can actually simplify this to be x equals 1.5. That is your axis of symmetry, or your AOS. Okay, so x equals 1.5. Now what we want to do is we want to plug in this number into our equation to get our vertex. So I'm going to go to the side, and I'm going to write finding vertex. finding your vertex, and our equation was x squared minus 3x plus 2. We're going to plug in a 1.5. So f of 1.5 equals 1.5 squared minus 3 times 1.5 plus a 2. You do all this handy-dandy work in your handy-dandy calculator, and I get negative 0.25. Which means our vertex, remember this is your x, this is your y, don't ask why. And I get my vertex to be 1.5, negative 0.25. Here's the issue. Whenever we look at a table of values, we only have whole numbers as our x values. We have a 1, a 0, a -1, a -2, a 3. So we need to figure out now, how do we find it based off that information? So here's the thing. Right now what we're going to do is we're actually going to copy the table of values from Desmos or our calculator down below. So again, this is your work for this question. Now we're going to go down just for the exact same equation for y equals x squared minus 3x plus 2. I'm going to write it out. So y equals x squared minus 3x plus 2. So our table of values, we know that our axis of symmetry is at x equals 1.5. So when we do our table of values, we want the values around 1.5. So I'm going to draw on my table of values. And it's not going to be perfect. So you want the numbers near positive 1.5. So when I do that, I basically just choose 3 numbers above and 3 numbers below. At -1, when I plug it in, I get a 6. 0, I get a 2. 1, I get a 0, sorry. At 2, I get a 0. 3, I get a 2. And 4, I get a 6. So looking at this, I really can't figure out my axis of symmetry. I can't even figure out my vertex because this is one of the cons of the table. It doesn't take into account the possibility of getting a decimal. So what we need to realize is that right here, in this little gray territory, is where my vertex has to be. Even though you don't see it. The reason why your vertex is appearing there is because, look, I can't have a vertex at 1, 0 or 2, 0 because it's basically saying that those points repeat. That's where my pattern is lying. This is your turning point or your vertex because this is where the pattern starts to repeat. Look, I have a pattern of 6, 2, 0, and then I have a pattern of 0, 2, 6. We need to make sure that that pattern stays alive. So, for instance, I can say that my axis of symmetry has to be at 1.5, and then whichever number I plug in. And when I plug in, I think we said we get negative 0.25. That's where your vertex is. Your vertex is not appearing in your table of values. It appears between your 2 pattern points again. So, here's what you got to do. You now know how to find the vertex in a table of values when it doesn't appear. Here's the issue. You must graph the vertex of a parabola. Now you know how to find it. You use the axis of symmetry, or you look at your table of values and be like, oh, my vertex doesn't appear, so I gotta do it again. All right, so here's how it works. Watch the video again if you're stuck. Once you finish that, do your independent practice. That's all due on Friday. And make sure that you write a question you have after watching this video. If you don't have any questions, please write down a noticing. That does count. Those are not accepted late. And make sure you are working on your weekly homework. Thanks and have a great day.